my stuffed raccoon is showing this barcode. At this point, it's unreadable. So the camera's going to move to it, it's going to zoom in on it, read that barcode, say read the barcode, and then you're going to see the mounting box go away because we filter that out of our set afterwards. And we say, okay, we've read it. We don't need to read that again. So now the camera's going through the zoom operation. Now it successfully read the barcode, it zoomed in enough, and now it forgot about it, right? So we can go to the next thing. Hey, everybody, I'm Luloy Zidis. I'm an implementation engineer with Roboflow. And basically what we do as implementation engineers is take the Roboflow platform and bring it to our customers. And Roboflow is a vision platform. So it's, we do a lot of things like manufacturing inspection and stuff like that. But we also take inventory in rail yards. We look at big turbines and engines and things like that. And we do inspection on these giant things. We may go to warehouses and read barcodes as we put pallets on a shelf. So we have this very broad range of applications. And because of that, one camera doesn't always cut it, right? So if you can imagine, if you have a giant warehouse with shelves all over the place, you have a few options, right? The one option is I could put 20 cameras in there and I could have one camera point into each of these shelves. And in many cases that works, right? There are pros and cons to different approaches, but we have started to use PTZ cameras in a lot of applications. And by PTZ, what I mean is pan, tilt, and zoom. So you get one camera that can move to all of these different locations, and you might lock into an event and say, hey, when I put this thing on the shelf, I want my PTZ camera to look at that and zoom in and examine this thing. So in this case, the PTZ can be a far simpler solution. Like I said, there's pros and cons, and I'm not necessarily going to get into that. But what I'm going to show you guys is how to actually use PTZ cameras with Roboflow. So here's a quick example of a PTZ camera moving, and I have a blog post about this that's going to accompany this webinar. So there's a lot more detailed information in there if you guys want to go take a look afterwards, and I'll kind of go through some of the ways to use this block. But basically what you're seeing right now is this camera is actually following that object, right? So if you think about in terms of Roboflow, what's the easiest way to make a PTZ camera work? It's to follow an object. But I mean, what we do, like our core competency, we have different types of vision models for sure. We do like OCR and segmentation and things like that. But it all started with object detection, right? So detect an object, if I could say, hey, in my frame, there's some objects and I just want to move the block to that object, that would be the simplest way of using a PTZ camera. So that's the way this is going to work. And within the context of Roboflow, you can code everything in Python, or you can use a workflow, which is our graphical platform for building the CV logic together. So I'm going to show you how to do this in a workflow, and it's going to be super simple. There's a lot of things to consider with PTZ cameras. Picking the camera is probably the most complicated part of this. Integrating it is going to be very simple. As far as picking a camera to use, right? So there's a few requirements I want to talk about right off the bat. One of them, obviously, you need some way of ingesting video into Roboflow. 90% of the time, maybe 99% of the time, that's from a PTZ camera, that's going to be an RTSP stream. If you have a camera that can act as a webcam or has some serial input, that would work as well. Actually, that could work better if it's an option, because RTSP buffers, it has lag. And that's one of the things I'm going to talk about. And lag's going to be the enemy of trying to control these things, right? But I'd say for the context of this discussion, and in most cases, RTSP is going to be what you end up using. The next is going to be ONVIF-compatible. So ONVIF is a protocol that a lot of PTZ cameras have, that it's used from everything from administration, logging into a camera and setting things up, to controlling the motion. In this case, we're going to control the motion. And I could talk a little bit more about ONVIF when we get into this, but it's basically a SOAP XML protocol. So it uses an HTTP connection with the camera to basically send the commands over. And it has different services within ONVIF. So we use something called the continuous move service. For instance, there's an absolute move service where I could say to the camera, move to a coordinate. But almost, I'd say the majority of PTZ cameras that are out there don't have a coordinate system, because that requires an encoder. So if you're buying some $50 off-the-shelf PTZ camera, that's not going to have an encoder in it, which means absolute move is not going to be available. Continuous move basically just tells the camera, move at different speeds, move my pan at a certain speed, move my tilt at a certain speed. We're using continuous move because the majority of cameras will support it. When you go buy a camera, it's very unlikely that it's going to tell you what ONVIF services it supports. It's probably just going to say if it's ONVIF compatible or not. It's a pretty safe bet that most cameras will support continuous move. So for now, we use continuous move. And there's also another service called Go To Preset. If your camera supports presets, there's capability to use presets in the block too and have your camera move to a certain position. Or if it's following an object, when that becomes idle, it for some period of time, 5 seconds or 10 seconds, you can say move back to a preset. And that's really helpful in like the inspection situation for instance, or let's say if you're reading things put on a shelf, you can move back to some idle preset and say, okay, wait for the next thing to happen. And then when I detect that next object, go and move it. But it's not necessarily, the block doesn't have to move it. And depending on the camera, if you have an encoder, you may be able to set an arbitrary preset, or some presets are just like move all the way to the right or move all the way to the left. So the next requirements I'm going to talk about aren't necessary, but are really helpful to have. Variable speed is a huge one. So I'm going to get into why that's important on the next slide. But generally, since you have RTSP lag, the only way you can really accurately control these cameras is with a PID loop. So if you're not familiar with PID, it's basically if you think about, for instance, with a temperature control, like with a thermostat, right? You turn your thermostat on and off, and maybe you stay within 1 degree of your temperature. That's okay, and it's necessary. You can't hit the temperature exactly because there's some thermal lag in there. If you want to consider the thermal lag and have better control, you need a better control system that considers the lag, and that's what a PID loop does. So you can put constants in PID control and say, okay, I'm expecting a certain amount of lag and try to accurately hit that temperature. If you watch like the temperature control on a 3D printer, for instance, it's usually controlling the temperature to 0.0 degrees, unlike your thermostat that just turns on and off, and that'll have a PID loop in it. So it stands for proportional integral derivative. I'll talk a little bit more about how that gets configured, but the key is in order to use PID, you need variable speed. Without that, it's really hard to deal with the RTSP lag. If you have it configured as a webcam and there's no lag, then it probably doesn't matter. You don't need variable speed. You can move as fast as you want and just say to this thing, stop when you hit the object. If you have variable speed, then you probably want a position coder in there. That's only going to be available on higher end cameras. The other nice thing the position coder gets you is those arbitrary presets. And then the other consideration is the RTSP delay. This can vary wildly from camera to camera. I have lots of PTZ cameras, and I have PTZ cameras where that delay is like 20 or 30 seconds. There's no chance of controlling those with this block. Ideally, I'd say you want a delay of a couple of seconds. You can probably deal with 5 or 6 seconds even if you really slow down the camera and adjust those parameters. Once you get to like 20 or 30 seconds, that's way too much. So you want a minimal RTSP delay. So I'm going to talk about video lag a little bit more because this is really the key thing to consider with this block. The block, I'll show you guys how to put it in a workflow. That's very simple. Lag is your enemy. If you have too much lag, you are not going to be able to successfully control it. And I'm sorry, this is a little bit hard to see. I probably made this text a little bit small here, but you can go read about this in the blog. By default, inference puts a buffer on there. So first you have your RTSP lag from the camera. Then on top of that, you put a buffer in Roboflow inference. We have 2 types of buffering. One is eager, one is lazy. By default, we use lazy, which puts a very large buffer in there of several seconds. The advantage is the video is a lot smoother. You always want to switch this to the eager buffering. Eager buffering, you'll notice almost no difference between Roboflow inference and the RTSP lag. It's possible that if you don't have enough processing power, you could get choppier video. I haven't really seen it happen too often, but since lag is your enemy, you want to make sure you use the eager buffering. And this video, which is also in the blog, you kind of see what's going on here, right? So if you see, that's the RTSP stream. So you see how much lag there was right off of there in the bat. That's right off of the camera. This is not even going through inference yet, and you've already got like 2 or 3 seconds of lag in there. So now if you put an inference and you put an eager buffer, you won't notice much of a difference. It's going to be about the same, that 2 to 3 seconds. So right there, that's what we want. We want to reduce that lag as much as possible. This is the default lazy buffer, and you're going to see how much lag you have here. You're waiting, and eventually you're going to see that object move in front of the camera. So imagine this from a control standpoint. If I'm controlling my camera to follow that item, to follow that object, when you have that much lag, how do you tell your camera when to stop? Your camera doesn't even know it's hit the object yet, right? So that's really your enemy from a motion control perspective. So now I'll show you how to go into here and actually use this PTZ block. So now we're going to get to the fun stuff. So first, I'm just going to create a workflow, right? Standard workflow. There's nothing special about this. The first thing we're going to want to do in here is, let me zoom in a little bit, is add a model, right? So I have some models that I use for this. And I'll show you if I demo, I'm able to demo the camera. Hopefully it'll work. Okay. So I'm in a hotel room and I'm traveling. This is the one I used for the blog post, this raccoon model. I just created one of my fists too. So I don't want to carry the raccoon around with me. So I'm just going to put this fist model in here, right? Which is just my hand as a demo. And really at that point, so if you're familiar with workflows, and, again, I didn't give a proper introduction to workflows, but this is really our graphical way of building computer vision logic, as opposed to using our Python SDK, or you can use a mix of both actually, right? I can add inference, run the workflow, and then put some Python around that if I want to. I'm actually a big fan of workflows, and that's one of the reasons, instead of writing the PTZ logic around there, I wanted it as a block in the workflow, because I think this is, even if you're a seasoned Python developer, the workflow it's far more maintainable. It's nice to be able to have all those different blocks you can put together, because you can go make edits to this easier. You can pass it off to customers or clients, and you guys are consultants, and show how the logic works much easier in a workflow. So I'm a big fan of trying to put whatever in workflows that I can. And by the way, this is all open source. If anybody on the call wants to add workflow blocks, we welcome contributions. But anyway, getting back into the workflow with the PTZ block, right? So I created a model, and I created this model actually in the hotel room, mostly very quickly, just using auto labeling. I took the camera and I grabbed a bunch of video of my hand moving around. I used auto labeling to label that, and I had a model built in about 10 minutes to be able to use that. So next, what I'm going to do is I'm going to add another block for the PTZ, right? So now this PTZ, by default, the workflow assumes I want to connect that to my object detection model, and that's not necessary. You have to put whatever the input is in here, but it needs a prediction to work off of. So within that prediction, this is what we call a kind in a workflow. It's going to not only contain information about the predicted about the objects that it detects, but also the original image. And in order to control that PTZ camera, what we need to know is where the object detected is in the context of the original image. So I could say, hey, you're over to the right. You got to move a little bit this way. Or you're up in a corner. You got to move a little bit this way. And as a result, the PTZ block doesn't actually need any image information. It only needs predictions. So I'm going to put the predictions in here. 192.168. So I have this camera set up right here, and the ONVIF port is 80. One thing to consider, by the way, with ONVIF that I should have pointed out is, in a lot of cameras, you have to turn that on, right? So for ONVIF and RTSP, they're not always enabled by default. So if you get a camera, make sure you go into the configuration and check. I'm still using the default camera password on there. And then we have some additional properties here. There's actually two movement types, right? Follow, which is going to be the default, follow an object in most cases. That's what most people are going to use. There's also a go-to preset. And if your camera supports presets, so consider like the application I keep referring to with the objects on a shelf. We want to go scan the barcode. There's two ways to look at that, right? One, detect the object and move to the object. Or the other one, maybe I can, if I got 6 shelves, I can make 6 presets, and I can put the logic in my workflow, because you can put conditional logic in here too to say move to certain presets as things happen. So that's a whole nother way you can create your application. Simulate variable speed, that's for lower end cameras. I'm not going to talk about this much on the webinar, but you should read the blog post on that, especially if you're using a lower end camera. Zoom if able. So when we lock onto the object and we have it centered, then it'll go into a zoom to try to get the object to get the object's bounding box to fill up the frame. That's really good for inspection applications. I'm not going to enable it for the simple workflow for now. One thing to keep in mind is currently the block cannot zoom and pan and tilt at the same time. So it's going to do a pan tilt, try to center the object, and then zoom. There's certain ways that zoom affects the motion, and there's a reason that, at least in this version, it doesn't happen at the same time. This is an important one, follow tracker. So those of you who use workflows before might be thinking, I put the object detection model in here and I send it right to the block. Which object does it follow, right? If I have 5 objects in my object detection, which one is the camera actually following? By default, it'll lock onto the highest confidence object. Generally, when you're creating the application, you want to think about what object you pass to it, because there are different ways of filtering and passing the object to the PTZ tracking block that I'm not going to do in the simple workflow. But by putting a tracker on it, what that allows you to do. So if you're not familiar with trackers, trackers are when you go from one video frame to the next, puts an ID on there and it says, this is the same object in each frame. And then the workflows run on the individual frames. Putting a tracker onto it allows the PTZ block to lock into an object to say, okay, I picked the highest confidence object, then I'm going to follow this object until the object's done. Without the tracker, it'll keep locking onto that highest confidence thing. So, that it could be a problem, right? If I'm following my hand and then I put my other hand in there, which one is it following? The camera's going to go nuts trying to figure out which thing am I moving to. Putting the tracker in there solves that problem. And I'll add a tracker in a minute. I'm going to go through the rest of these settings first. There's a dead zone, right? And having a dead zone is good so that when you actually center the object, the camera stops. You want some amount of dead zone in there to avoid hunting. And when I say hunting, what I mean is the camera moves, overshoots a little bit, moves back, overshoots a little bit, moves back. We want to avoid that. The default position preset. So in this camera, the presets have numbers. They're just strings. Some cameras, it'll be something like, for instance, in my FOSS cams, it's like, you only get a certain number of presets like that because the camera doesn't have an encoder. But the camera I'm using right now has presets, which is nice. You could put something in here and say, after the camera's been idle, move to that preset. I'm going to avoid that. The update rate limit. So every time this workflow runs, it's going to recalculate which way the camera has to move and send that over to the camera. Since this is an HTTP protocol, you probably don't want to be sending updates to the camera every 5 or 10 milliseconds. So this lets you limit the rate, and the stop commands, they're always allowed. At least the first stop command is. This is something to consider. ONVIF is kind of second class by most of these camera manufacturers. Usually they have their own SDKs. In the camera I'm using, for instance, what I found was that if I try to send zoom commands faster than twice a second, it just starts ignoring them. So if I wanted to use zoom, I'd be setting this to 500. Don't let it go more than twice a second. For now, I think 250 is a default for updates a second. Seems to work pretty well, but that might be something you have to experiment with. Flip X and flip Y movement, that's only if you mirror the images. You usually don't have to worry about that. Minimum camera speed, I'd leave this at the default. I found that some cameras just stop responding if you set it too close, if you set the speed too close to 0. So now these 3 are the important parameters. These are the PID constants. Right off the bat, I'm going to say ignore KI, right? This is a steady state error. I don't see how you would get a steady state error in this application. Generally, KI, just leave it at 0. That's the default. I've even considered maybe taking that field off of this plot. The 2 important ones are going to be KP and KD, right? The way to think about KP is, the speed will vary, but in some sense, it's your speed control. You increase that number, the camera's going to move faster in general. If you decrease that number, it's going to move slower. What you want to do when you're tuning the PID is start this at a low number. I have 0.25 here as the default. I'd start somewhere like that, increase it until the camera overshoots, and then decrease it to just to the point where it overshoots, and then maybe just decrease it a little bit, right? That'll tell you how fast you can go without a lot of hunting. Then you want to increase KD to try to reduce that amount of overshoot, and sit and think about that as a dampening command. I found, like, for this application, I'm using 2 and 1, but those can vary wildly from camera to camera. And so now what I'm going to do is, okay, so I have the object detection in here. I have the PTZ track, and the only block I'm going to add right here is this byte tracker, right? So this is your tracker. This is the one that's in here in general. And of course, I put it in the wrong place. So what I want to do is put byte tracker up here before the PTZ block so that I can pass the trackers to it. So I'm going to put this off to predictions, and then basically this is going to now take it from track detections and byte trackers. And this is about how you want the workflow to look. There's a couple of other things I can add in here, such as, putting the bounding boxes on here and things like that. So now what I'm going to do is I'll show you real quick. I have this workflow running from one that I had already created. And let's see, QuickTime. So you can see the camera down here. And if I put my fist in front of here, and in this workflow, I actually do have a tracker, right? So you see it moves to where my hand is. And I have the proportional constant set pretty low for that, which is why the camera is moving so slowly. I think I can speed it up, but I started to get a little bit of hunting, and I didn't necessarily want that in this application. One thing to keep in mind too, actually, I made this fist model pretty good. You know, it'll move over, but if I, see how every now and then the bounding box comes off of the hand. That's one thing to think about with your model. Like, do you have to go and fix your model so that the bounding box is tighter or on there more often? Does it disappear? You know, when I put my fist close to the edges, if it disappears, then the camera's not going to follow it, right? That light above me, I had an earlier version of the model where it was detecting that as a hand. The camera kept moving up to it, and that's going to screw it up. So think really hard about building a good model with a very tight bounding box. Let me shut this off for now. Another thing I can show you too while I have this running, if you use Wireshark at all, I don't know, this might be probably for more advanced technical users. But if you use Wireshark at all, it's a good way of debugging because you can also take a look at the commands that are sent to the camera on here. Right, so you see there's a continuous move command in here, and it'll actually show you. You can see right in here what numbers that we're setting over to pan tilt. And right here, you'll see it's 0 and 0. So that would effectively be a stop command sent to the camera. So if your camera's doing something funny or moving in some funny direction, you can get Wireshark and you can go look at what's being sent to the camera and make sure it makes sense. Like on this particular camera, I found sometimes when I send it extreme pan and tilt commands at the same time, it just does something funny. I don't know if it's freaking out or what. So reducing that proportional constant actually helped a lot with the camera control. And so there's some finicky things you might have to consider in there. It can get a little bit technical, but in general, really using this is as easy as adding this block. Let's see, going back real quick. So I'm going to try to wrap this up. So now, that's the simple application. If you're doing something with this and all you want to do is like a security application, follow some person as they're moving along with the camera, what I showed you, that workflow, that's all you need. That's enough, right? And maybe you can even integrate something in there, like send an alert, send an email, send a Slack alert. That's all in workflows too. If that camera moves and detects something, take some action. But if you want to do something like a more complex inspection type application, the key things to think about in here are, so first you do the object detection. The example that I just showed you, I just had it detecting any object. I could put both of my hands in front of that and I wasn't filtering either of those hands out of the camera. So you need to put some kind of filter in there to think about what object you actually want the camera to follow. Then you do some of that. It's okay. So imagine, somebody the forklift comes and puts this pallet on that shelf. Now here's my event. Now I want to move my camera, right? So you pass that object into there based on the event. Then after you take the inspection, what you want to do is, if you're using like Byte Tracker or something, say, hey, this tracking ID, I've already inspected that. Filter that out of the object set that I'm passing to the camera. Because if you don't do that, what's going to happen is the camera's going to be tracking the object. Maybe it goes back to a preset, then it finds the same object again and immediately moves back to try to track that object. And that's not what you want in the application. So really you have to focus on, how do I filter out the things I actually want the camera to follow? I'll show you very quickly. I don't want to get too far into that. Again, this is all in I go into detail on this in the blog, but I have some custom Python in here, for instance, to filter out the tracked IDs. I won't get into the nitty gritty of this, but it's a very simple thing. If you look at the object detection kind, you'll see how the tracker ID fits into there and how you can filter out the IDs that are already tracked. And we have these functions called cache get and cache set to save. So where you can save something and a value in there and recall it in a future workflow. In this case, I'm saving the set of tracked IDs and filtering them out later. And then once we do the actual tracking in here, I save those tracked IDs and I send it over to that cache, right? So that I can filter them out of future workflows. In this case, what this actual workflow does is it's got a number of idle seconds on there. And if it's waiting for that long, if it's idle for that long, it's going to say, okay, I've already tracked this. Actually, you know what? This is a relic from that. That's, if you look in the blog post, that's the first way I described it. And I think I left this constant in here. In this case, actually, what this is doing is it's going to read a barcode, right? So you see we got a barcode reader block in here. And this is just a model to read a barcode. So the next video I'm going to show you, the camera moves. It sees that there's a barcode there, but it's not zoomed in enough to read it. So then we use the zoom capability in the PTZ block, zooms in. Once that barcode's clear enough and we can read that barcode, now we say, okay, we've read it. And we tell our future camera based by putting in that cache to say, okay, forget about this barcode. We've read it. Let's wait for the next barcode. So I'm going to show you that real quick, and then that'll be the last thing I show, right? So in this case, I have my. By the way, if you're not familiar with Roboflow, we love raccoons over here, and that's why I keep using the raccoon stuff. In fact, our mascot is a raccoon, Lenny. But you'll see Lenny's. Well, this isn't really Lenny because Lenny's purple, but my stuffed raccoon is showing this barcode. At this point, it's unreadable. So the camera's going to move to it. It's going to zoom in on it, read that barcode, say I read the barcode, and then you're going to see the mounting box go away because we filtered that out of our set afterwards. And we say, okay, we've read it. We don't need to read that again. So now the camera's going through the zoom operation. Now it successfully read the barcode, it zoomed in enough, and now it forgot about it, right? So we can go to the next thing. And so that's kind of, when you think about the inspection workflow, you need to think about, how do I pass the actual object I want to read to the camera? And once I've done what I need to, how do I get rid of it? And so that is my presentation. So thank you everybody for joining, and hopefully you'll build some great things with PTZ cameras.